Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. What if tomorrow was to never come again? What would you do one more time? I know the answer to that. You would do some calculus. That song was played by the request of the great Yorgi, and I'd try to pronounce his last name, but I'd butcher it because I don't think I've ever heard it pronounced. So I will ask him tomorrow. Let's take a nod to the great Gottfried Wilhelm Leibniz, and the impeccable, improbable, the unbelievable Sir Isaac Newton. Here we go. You know that if you take the derivative of a cost function, c of x, you will get the marginal cost. Hopefully you know that, of producing x earns per week, which gives you the cost of producing the next item. In this case, an earn, U-R-N. You can't really see that. Oh, you can see it there. So we have the marginal cost function here, provided that we're producing between 0 and 120 earns inclusive. We know the initial cost before production starts is 100 or are $185, and we have to find how much it costs to produce 100 earns. So the cost function is going to equal the integral of the marginal cost. So that would be 2.15 minus 0.02x plus 0. I hate all these zeros, 0.0036x squared dx. We take that integral, that is equal to 2.15x minus 0.02x squared over 2 plus 0.000036x cubed over 3 plus c. So that is our cost function. Say yes, yes. But we know that right here that c of 0 is equal to 185, because before we produce any earns, the initial cost, $185. So replacing x with 0, there goes my phone. Replacing x with 0, we would get little c, our constant, is equal to 185. And if you don't mind, instead of rewriting this nonsense, I'm going to erase little c, replace it with 185. Wham, bam, wham, wham, bam, I don't know. Now I just have to replace x with 100 to find the cost of producing 100 earns per day. Replacing x with 100 here, here, and here, and doing all this silly arithmetic. That gives me a total of $420. So to produce 100 earns a day, it would cost $420. One more example. So we have the cross section of a metal tube. The outer radius is 4, so from here to here is 4. And the inner radius is 2, so from here to here is 2, and we're talking centimeters, I hope. So the water temperature in here is 100 degrees Celsius. And within the metal, the temperature drops off from inside to outside according to this function, where x is the distance from the central axis, and it's between 2 and 4 centimeters inclusive. So that makes sense that the temperature, you have your temperature in here at 100 degrees Celsius, so it's going to be warmer closer to the center than it is further away. Find the temperature of the outer surface of the tube. Holy smokes. Well, we know that the derivative of the temperature with respect to x is equal to negative 10 over x. So if we take the integral of the derivative, we get the original function. So the temperature is going to equal the integral of negative 10 over x dx. And hopefully you think you're screaming, natural log, logarithm. So that means 10 is equal to negative 10 natural log absolute value of x plus the constant c. Okay? But we also know that when x equals 2, the temperature is equal to 100. How do we know that? Because that's right at the edge there. It's 100 degrees all the way around. Okay? How can that help us? Well, we can do a little bit of substitution here, right? So I'm going to replace T with 100. So 100 is going to equal negative 10 times the natural log of 2 plus C. And solving that, we get C equals 100 plus 10 natural log of 2. Okay? And so therefore, I now get T equals negative 10 natural log of x. Why did I not include the absolute value from here? Can anybody tell me? Can anybody tell me? X is going to be greater than 0, so there's no need for it. Correct? Correct. Okay. Plus C, so that's plus 100 plus 10 ln of 2. And it probably would have been nice if I did T of x here. T of x, right? So we clean that up. Hopefully you remember your rules of logarithms. So 100, this is 10 ln 2 minus 10 ln x. So that's going to equal 10 ln of what? 2 over x. So 10 natural log of 2 over x. Why did I put that natural log way up there? I don't know. Let's put it here. Natural log. Okay, good. So when x equals 4, so T of 4, that's the outer temperature, is going to be 100 plus 10 times the natural log of 2 over 4 is 1/2. Bam! And so we crank that into our calculator, and the temperature of the outer, let's see what to say, of the outer surface would be approximately equal to 93.1 degrees Celsius. Hope you enjoyed that. I certainly did. And we will see you next time. Let's see how Yorgi's song is doing. Let's crank up the tune. Oh, doctor. It's beautiful. Thank you, Yorgi. And I am out.